So yeah, this is biomaterials for the fourth semester, and it is mandatory. Sometimes we put it as subject for oral final exam. Your batch is the last to have oral final exam. Yeah, the new curriculum students, the batch 2020, the junior, your junior, does not necessarily have to do oral final exam. But your batch, unfortunately or fortunately, depends, depending on your point of view, has to do oral final exam. That this is will be in the semester 6, semester 8. Yeah, before you can do thesis, you have to do oral final exam, and usually it consists of two mandatory subjects, yeah, and one elective subject. The mandatory subjects usually it will be uh, biomedical instrumentation and biochemistry or sometimes biomaterial, yeah, sometimes biomaterial. Yeah, excuse me. And but in the last officer, the mandatory subject was biochemistry, but now it was the 1 year ago it was biomaterials. Yeah, it was biomaterials. Then the elective subject you choose from three different subjects, which can vary uh, from batch to batch. The last one was the three option was uh, algorithm and data structure, then biomechanics, and the other one I forgot what it is. So let's go back here to biomaterial. So the subject will introduce you basically to the fundamental and recent advances of biomedical material. Yeah, it will cover a broad spectrum of biomedical material. So basically the idea is to give you some basic knowledge on the materials that are used or that are being used in biomedical devices. Either it is instrumentation or implant or any diagnostic or therapeutical device. And this include usually metals, which is still one of the most widely used biomedical materials. But there is also increasing use of ceramics, especially in the fields like dentistry. Then polymers is in the field of wound healing and also some other thing. Yeah? And composite. Actually, the subject will also include new advanced material. For example, those materials derive from biological materials, yeah, like stem cells for regenerative technology. Actually, like the guest lecture that you have to attend this Friday session, this Friday afternoon. It maybe is related with the advanced material coming from bio biological material. Yeah, biological material. Biological material means here materials derived from biological organism. Could be from bacteria, could be from uh, fungus, could be from mammalian cells, etc. So we will be exploring again the chemistry and the physics of this material, their biocompatibility, and the consequences of implantation of this device into human body. What happens during the implantation? Then we will also explore the mechanical properties, characteristics of the materials. So, for example, like stress and strain, fracture, fatigue, wear, corrosion. So after this finishing the subject, you are hoped to be able to differentiate the characteristics of internal structure of engineering materials, interpret the relationship between structure and properties of engineering materials because these two are related. Yeah, the structure will determine the properties in any types of material. Investigate and know why, how biomedical materials fail. For example, in implant, why sometimes materials fail. Then determine the suitability of biomedical materials for hard tissue and soft tissue replacement. Then elaborate on the various tests for biocompatibility and biofunctionality. So the biological aspect will be covered by Pak Kholis, yeah, like biocompatibility, biofunctionality, immunoreaction, etc., etc. So this subject will cover some key concept in material science and engineering. We with 3 semesters, with 3 SKS, it is actually not enough to cover all aspects of biomedical material. Even in the new curriculum, it is reduced to two SKS because we need to cover other subjects as well. So this is basically just to introduce you to the basics of material science and engineering. So we will introduce some aspects on processing, structure, properties, and performance aspect. The emphasis will be on the application and implementation of this material and for the development of biomedical devices, either for diagnostic or therapeutic, especially class 3 devices. Class 3 devices are biomedical devices that are implanted into the body, inside the body. So they interact closely with the human tissue. Class 2 devices, on the other hand, attach usually to the outer surface of the body, yeah, the skin, etc. While class 1, they do not interact at all. So the critical part in choosing material for biomedical application is especially in class 3 devices, implantable devices. So we will basically still use the conventional method, yeah, online learning like this, but discussion and homework and quizzes, and 40% will be based on this mid-semester assignment, while 60% based on final examination and projects. So there will be project, and perhaps college will give you assignment as well. From my side, I think the project will be combined with sensors. I'm not sure yet. Most probably like that. So because basically you are also taking sensor and measurement subject. So the same project may be related or maybe use the mark for both subjects, for either, yeah, the sensor measurement and the biomaterials. Alternatively, of course, we can have different projects depending on the situation. So what are the contents of the subject? So we will cover, of course, the basic first overview of biomedical materials. What materials are? First is the types of material. Then the atomic structure and interatomic bonding. So we study the structure from the basic building unit of material, in this case the atoms. And but the chemistry, in chemistry you also studied that, yeah, those things. So the difference that in material science and engineering we also study a higher level of structure, in this case the interatomic bonding, as well as the structure of solid itself when it builds into the larger scale. For example, later the crystalline structure, yeah, and its properties. Then after that, we will study some characteristics and properties of material. Especially emphasis will be given on mechanical properties. Yeah. Since this is the most widely used properties of the material in the biomedical application. Yeah, like for the bone implant, currently, yeah, the current bone implant, etc. In the future, of course, biomedical material will also perform other functions and will implement or exploit other properties of materials such as electronic properties, optical properties, etc. But so far, not that many applications in biomedical science and biomedical world that use the other properties outside mechanical properties. Not that many. There are, but there are few of them being reported, but not yet. I'm, I think it will be growing. It will be a growing uh, application of biomedical materials where other properties of the material are being exploited. Not only the mechanical properties, but the electronics and perhaps the photo optical also. The biological is, of course, yes, because the material will interact with the biological tissue. Then we will study the different types of materials, biomedical materials, metallic biomedical devices, ceramics biomedical devices, then polymeric devices, polymeric implant. I think I forgot here, there will be also composite. If there is time, we will study some composite biomedical devices, composite biomaterial, and the structure and property relationship in biological materials. Interaction of material with biological system. This is will be covered by Pak Kholis. Biological testing of biomaterial also with Pak Kholis. Transplant tissue engineering. This is Pak Kholis as well. Then application of tissue engineering, medical devices, and advanced therapy medicinal product. And then of course case studies and projects. So this first week, this is we will cover this overview of biomedical materials, introduction, historical development, definition, requirement, advanced material, introduction to advanced material, modern materials need, and the relationship between processing, structure, properties, and performance. These four keywords are important. Then about atomic structure and interatomic bonding. Then the structure of solids, characteristic, after which then we study the characteristic and properties of material, imperfect, how actually the structure will determine the properties. So for example, in metallic devices, yeah, there is imperfection, diffusion, dislocation, and strengthening. Then we study, if there is time, this is a little bit very material side, but we will introduce you a little bit, phase diagrams, phase transformation, microstructure and alteration of mechanical properties. Then some other material properties, yeah, thermal, surface electrical, magnetic optical absorption of X-ray, acoustical, ultrasonic density and porosity properties of material. Then we study the materials based on the types, the metallic biomedical devices, for example, like metallic alloy, metallic implants, hard tissue, long bone repair, etc. Then ceramic biomedical devices, the processing and the structure and their application. Then the polymeric implant, the chemistry of polymer, the structure properties and processing. After which, then the composite biomaterial, the structure and processing. Then by starting week 10, it will be Pak Kholis' turn to teach you structure property relationship of biological material, interaction of material with biological system, biological testing of biomaterial, transplant. Yeah, this is using either from the same person or from the different person. Yeah, what we call as, or from different species. Transplant. The immunological consideration, organ regeneration. Then tissue engineering. So in tissue engineering, we grow the tissue. Yeah, I think this is the one that will be presented by the Japanese professor this Friday. Scaffold materials regeneration, cellular aspect, various example of organ regeneration. Application of tissue engineering, yeah, the advanced application. Then week 14, you will present your project, or week 14 or week 15, depending on the situation. Okay, are there any questions regarding this? excuse me. Yeah, most probably there will be quizzes, yeah, to every time you finish a chapter. So to test your understanding, and there will for the mid semester assessment. Then there will be final exam and projects. Yeah, depending. Yeah, sometimes if the project is enough, we may not need to do final exam. Depends later on the situation. Any questions so far?
Not yet, Pak.
Not yet. Yeah. Okay, if there is no questions, then I would stop this and